Okay, so we're going to solve things, and kind of our trick on this is to isolate the trig function. So I want to get to like a sine equals, cosine equals, secant equals, whatever equals. And then we can use our unit circle to find the solutions. So it's probably going to be easiest if we can get things into terms of sines and cosines or tangent. We can do it with any of them, like totally fine. We're just going to have to remember our relationships. When it says find all solutions, that means I need to include coterminal angles as well. So when we're looking at sine and cosine, we're going to be looking at adding a plus 2 pi n so that we can get our coterminal solutions included. If we're looking at things that are tangent based, remember how tangent was undefined at our minus pi over 2 and our positive pi over 2? So if we look between, like on a half circle, so either on that negative 2 or negative pi over 2 to positive pi over 2, so either looking at it as a half circle this way, or if you think about it being a half circle this way, it gets you those same values. It would just be slightly different pi. But since tangent has a much smaller period, think about adding pi over n for our coterminals on tangent because it repeats itself twice in the circle. So sine and cosine based problems, we need to add plus 2 pi n to the end of our solutions. And for tangent, cotangent, we're going to add pi n. So thinking about those periodic shifts, those kind of things like we did in our graphing stuff. So what we're going to do is we're going to start with some not super duper complicated things. So our first one we're going to solve is going to look like this. We have 1 minus 2 cosine of x equals 0. We need to find x. We're going to get all the way down to x equals. So what could we do to get our cosine by itself? Say louder.
Subtract 1.
You can subtract 1. Totally fine. Absolutely valid way through this. So if we subtract 1 from both sides, then I have minus 2 cosine of x equals minus 1. Divide by negative 2. Absolutely valid. Divide this side by negative 2. Divide this side by negative 2. So that's going to give me our cosine of x equals 1/2. I like 12 emails right now. So then I want you to think about our unit circle. Think about our unit circle. And remember, our ordered pairs are usually our cosine and then sine. So which angles have a cosine of 1/2? We're typically going to do this in our radians. So what is it in radians? Pi over 3. Or pi over 3. Where else do we have a cosine of 1/2? Two pi over 3 would be this one, which would have a negative x value. Which one? 5 pi over 3 would be this guy down here. These guys both have our cosine at 1/2. It's just that this one has our negative square root of 3 over 2, and this one is our 1/2 and our positive square root of 3 over 2. So thinking about our ordered pairs that way. We're looking for where we had a positive 1/2 here. So we have two actual answers. We know that cosine of pi over 3 would give us a 1/2. So we could have that x equals pi over 3. And we have another option. X equals 5 pi over 3 would also give us 1/2. But we also need coterminals for all those. So I need pi over 3 plus everything that would be coterminal to it. So we're going to have our pi over 3 plus any number of times around the circle. So we could be plus 2 pi times 1. We could do plus 2 pi times 2. So I could go around twice. I could go around 5 times 2 pi times 5. I could go the wrong way around. I could take a minus 2 pi. I could take a minus 4 pi. And that would give me pieces that are coterminal with this guy, no matter how many times around the circle I go in which direction. So that's what this is saying. Is this saying all of my coterminal angles? Yes, dear.
But you wouldn't have to put like plus or minus, right?
Because n can be any integer, so it could be a positive or a negative. So that's right. That's why we don't do plus or minus. It's included in that n piece. So on our 5 pi over 3, we're also going to include that, plus our 2 pi n, because again, we need those coterminal angles. So we need to have this piece in here. It's really important. Okay? So that's what I mean when we said isolate our trig function and then think through our unit circle on here to find all of our answers plus our coterminals. Questions on this first one? We gonna do another? Naturally. Like if we just did one. Psh, psh. All right, so we've got sine of x plus 1, and we want to know when that equals the opposite of the sine of x. What's our instinct on this one? What you got, Zion?
Well, you could either, well, I would say subtract 1 and then add sine of x.
Yeah, that's my instinct on that as well. I want to get those signs together because, ew,
And that way sine's not negative.
then sine's not negative as well. We don't have to deal with that. So if we add sine of x to both sides, and then you can also do this at the same time, minus 1 from both sides. That's totally valid. That was what you said, so I'm just going to go with it. So I have sine of x plus sine of x. What are we going to get there? 2 sine of x equals a minus 1. There was a couple of steps in there. Everyone see what we did? What should we do next? Divide by 2. I want that sine by itself because I know the unit circle values for sine much easier than I know them for 2 sine. Ew. So we're going to get our sine of x is equal to negative 1/2. So again, then we're going to think about our unit circle. Cosine and sine. So now we're thinking about our y values. Which angles are going to have a y value of minus 1/2? Pi over 6. Yes. Well, it'll have a y value of 1/2. 5 pi over 6 gives us this guy. Oop. There we go. That guy. So this would be our negative square root of 3 positive 1/2. So it's close. It's got the 1/2, but it's not the right sign. So we would need our this guy. It's very similar. Super close. 5 pi over 3. It's also close, but not quite on it. We want to have our 7 pi over 6. We'll have our negative 1/2. And our 11 pi over 6 will also have that negative 1/2. So this is one of those things I was meaning like way at the beginning of the year when I said the unit circle is going to have our answers for a lot of the semester. Here we go, Exhibit A. So our 2 angles that are going to give us that sine of minus 1/2 are our 7 pi over 6 don't know why I wrote it that big. There we go. Our x is going to be our 7 pi over 6. And our x is going to be our 11 pi over 6. But we need all those coterminal angles as well. So we need to include our plus 2 pi n plus 2 pi n. So when in doubt with these, fill in a unit circle to have with you. If you ever need a copy of the unit circle, I have bunches and bunches and bunches of up there. And I can always make more. And if you need a dry erase copy to have, I can get you a dry erase copy to have. But we're going to need to know a unit circle very, very well. So this is going to have two answers for us here. This guy and this guy. Questions on this one? Okay. Now we're going to do a tangent one. And it's got a squared. Oh no. We can do this. So we've got tangent squared of theta minus 3 equals 0. Add 3 to both sides. Absolutely valid. Add 3. That's going to give us tangent squared of theta is 3. What can we do here? I was going to say, since we have a squared, we can square root both sides. You could absolutely have the sine over cosine route, though, too, as well. So I can square root both sides. When we square root both sides, that's going to give me tangent of theta is what? When we square root both sides of an equation, though, plus or minus. So it could be that we have a positive square root of 3, or we could have a negative square root of 3. So when we think about tangent, I don't need to do the whole unit circle, but we're also not as well versed in what our tangents are. So I'm just going to think about the top half of the circle. I'm just going to think it this way. And then I'm going to toss up our ordered pairs first real quick. So we have our 1, 0. And we're going to have our 0, 1. We have our 1 half square root of 3 over 2, square root of 2 over 2, and square root of 3 over 2. So there's our sines and our cosines. And remember that tangent is our sine over cosine. So if it helps to think about that, you totally can write this as our sine of theta over cosine theta. And we want to find our square root of 3's that are in our sine and our cosine that does not have a square root of 3. So in our first quadrant, this guy over here, which angle has a square root of 3 in our sine? Pi over 6 is this guy right here. Pi over 3 does. Because remember, it's cosine then sine. If sine has the square root of 3, even though these are both over 2, those guys are going to cancel out. So this is really square root of 3 over 2 over 1/2. So if our tangent equals that positive square root of 3, we're going to have our theta that is that pi over 3, right? Where are we going to get the negative square root of 3? What angle would that one be? Mm-hmm. Yeah, so it's going to be that reflection across over here, because if I fill in this guy, it's going to have those same values, just with our negative 1/2 square root of 3 over 2. And if I find my tangent there, sine square root of 3 over 2 over negative 1/2, we get our negative square root of 3. So our theta here would be our 2 pi over 3. So with our tangent, since it repeats around the circle another time, we're not going to add 2 pi to it. We add pi, since tangent's whole period gets covered in this span. So for our final answers here, we're going to have that our theta is pi over 3 plus pi n. And we're going to have, our theta equals 2 pi over 3 plus pi n. So we need to make sure we include all of our coterminal answers in our final answer when it says for all solutions. I think all the ones we're doing today say for all solutions. Okay. Questions on this guy? All right. Sometimes they'll get a little crazy looking. So we've got secant of x, cosecant of x, and we want to know when that's going to equal cosecant. When in doubt, get everybody together on one side. Set it equal to 0. So our first goal on this guy, ooh, that's not the one I wanted. We're going to set equal to 0. When we've got some kookiness happening, go for an equal to 0. Yes, dear?
Couldn't you just divide by cosecant and then it would be 1? Or no?
The only problem with dividing by cosecant is if we have something in a denominator that wasn't originally in a denominator, we can either get an extraneous solution or we're going to be missing one of our answers. So we don't want to necessarily divide by a variable. So if it was just like cosecant of 2, totally fine. But since x is what we're looking for, it can play games with either giving us an extraneous solution or we would lose out on a solution. So I'm going to go for a setting equal to 0, and we're actually going to subtract cosecant of x from both sides. So I'm going to minus cosecant of x. So that's going to give me secant x cosecant x minus cosecant x. Ugh. Equals 0. What do we notice on the left-hand side? I've got cosecant as a common factor between the two pieces. So let's factor out a cosecant of x. I can write this as cosecant of x times secant x minus 1. And now it looks an awful lot like a factored form situation, which is exactly how we treat this. So we want to know when is cosecant of x going to equal 0? And we want to know when is secant of x minus 1 going to equal 0. So when we have two factors, this is using one of those fundamental theorems of algebra. Since I have two pieces that multiply to make 0, either cosecant equals 0 or secant equals 0. Secant x minus 1 equals 0. One of those two chunks has to equal 0 for the product to be 0. So let's think about cosecant of x. Cosecant, that's the same thing as 1 over sine, right? What's going to go on here? if we have 0, if we have our sine being 0, so sine of x being 0 would be on angle 0, would that equal 0? It would be undefined. So 1 over 0 is undefined. So what we get is that this doesn't actually have a solution right here. There is no value for which this would equal 0. So there's no solution for this piece, just an exclusion of that x can't be 0. Because if x equals 0, we are undefined. So that piece doesn't have a solution. It just gives us like a restriction saying, nah, no, that don't work. So let's look at the right-hand piece, see what we can do with this. Our secant of x minus 1. Well, first things first. Let's get rid of that 1. Add 1 to both sides. So let's see if we can figure out where secant of x might equal 1. That seems more attainable. Remember that secant, that's 1 over cosine of x, right? So what do we need cosine to equal? 1. Cosine of x equals 1 is what we're looking for. So where does cosine of x equal 1? 0. Well, wait a minute. What did we just say? We said x cannot be 0 because that makes my cosecant undefined. So the only solution for secant is where my cosecant's undefined, so this whole problem has no solution. Which is obnoxious, but it happens. Especially when we're dealing with secants and cosecants, we gotta watch out for excluded values. If we have a 0 in the denominator, we are undefined. If it is undefined, it cannot be our answer. Okay. Where cosine of x equals 1 would be at angle 0. Because that's when we have our ordered pair of 1, 0. And these are always going to be cosine then sine, alphabetical order. So like this guy, I'll pi over 2, that's 0, 1, and that's cosine sine. So we're looking at that angle 0, that's this guy right here, because that's where we have our cosine of 1. It's also where we had our sine of 0, which was our problem piece. So we got to watch out for those undefined pieces. Questions on this guy? They're annoying and they're kind of weird, and sometimes they require us to look at things a little bit scary. The next one's going to look a little scary, but I promise it's okay. Because there's like surprisingly more numbers than we're used to seeing here. So we've got 7 cosecant of x plus 2 square root of 2. And we want to know when that equals 9 cosecant of x. So what should we do first? Yeah, let's get those cosecants together because I really don't like having them on opposite sides of the equal sign. So we're going to subtract our 7 cosecant of x from both sides. So we're going to have our 2 square root of 2 equals 9 minus 7 cosecant of x will give us 2 cosecant of x. I'm going to fix that x because that looks weird. There we go. Then what? Divide by 2. Let's get that cosecant by itself. So we want to know when the square root of 2 equals our cosecant of x. So remember that our cosecant, that's the same thing as having our 1 over sine of x. So we're going to look at our sines and see if we can figure out where that's going to be. So think about our unit circle. If we think about our pi over 4, I'm just going to write down, so we have our pi over 4, that's when we're going to have our square root of 2 over 2, square root of 2 over 2. So if we take our cosine, sine, our sine, and we put it 1 over, let's see what happens. What is, I'm just going to write it over here, our cosecant of pi over 4. That's when we have our 1 over square root of 2 over 2, right?
It's gonna be root 2.
Say it again, because I have no idea what you said there.
It's just gonna be square root of 2 because we rationalize.
Yeah. Because our initially we have 2 over square root of 2, then we have to re-rationalize it, so we get 2 square root of 2 over 2. But then our 2's just cancel out, and we're just left with square root of 2. So we can see that our cosecant, when our sine is square root of 2 over 2, gives us exactly what we're looking for here. So whatever pathway we take to get there, we know that one of our options for x is our pi over 4. Where else are we going to have our sine that has square root of 2 over 2? That's when our y's are the same, so it's going to be this guy over here, our 3 pi over 4. That's a 4. It looks straight up like a y, but that was a 4. So our pi over 4 is one of our solutions, and our 3 pi over 4 is one of our solutions, but we need to include all of our coterminals. So we're going to plus our 2 pi n to both of these. So it's thinking through our unit circle in a slightly different way. Sometimes we have to, that is not what I meant to do. There we go. Sometimes we have to think through this, especially with our cosecant and our secant, to double check that this is exactly what we want it to be. To double check those pieces, because we're given sine and cosine and we were looking for secant or cosecant. So we have to be really, really careful. Okay, but questions on this one? Because this is our 2 answers over here. These guys. Okay, we're going to keep going. So here's our next bit. We've got 3 square root of 3 times tangent of x. And we want to know when that equals 3. So we're looking at a tangent one again. What should we do first? Definitely want to divide, but what do we want to divide by? Yeah, we want to take this whole chunk away from here. I really want my tangent by itself. So we're going to divide by 3 square root of 3 on both sides. So we're going to have our tangent of x. Those guys cancel. Careful, because it's not just going to be square root of 3. It's going to be 1 over square root of 3. Because my 3's cancel out, and that square root of 3 is still in the denominator. I was if when we were rationalizing, it would be square root of 3 over 3. But we don't need to rationalize at this stage. And honestly, if we don't rationalize, it'll make it easier to spot your pieces that we're looking for on the unit circle. So if we rationalize, wait till the very, very end, because I'm going to show you a little trick when we look at our unit circle again. Dramatic. Stuff just leaping off my desk over here. On how to spot these on our unit circle, or in this case, unit semicircle. Because I'm just going to look at the top. With tangent and cotangent, we only need to look at half of the circle. So if I, again, think through our kind of basic-y basics, where we have our 1, 0, and our 0, 1, where we then have our 1 over 2, square root of 2 over 2, square root of 3 over 2, 1 over 2, square root of 2 over 2, square root of 3 over 2. There we go. So there's kind of our first quadrant. And we know that tangent is usually written as, like we could also write it as sine over cosine, that we have as 1 over square root of 3. What we want, look at our numerators. Sine to be 1, cosine to have a square root of 3. Which one has a sine that has a 1 in the numerator and a cosine that has square root of 3 in the numerator? 5 or 6. So we've got our cosine, sine. Numerator, denominator. So that tells me it's this guy right here. Okay, so by not rationalizing it, it lets us spot that as in the numerators of our pieces there. They should always be one of those pieces there. So our first option for x is that pi over 6. What other x is going to have that same I was going to say, when we get there, yeah, it's going to be actually our 5 pi over 6 right here, right? If we did, it would be 7 pi over 6 that would match. Because 5 pi over 6, it's going to have these same values, but one of them is going to be negative. So that would actually give us a negative square root of 3 in our fraction there. So 5 pi over 6 would be the same value, just not positive. So the only place it's going to have that same tangent is going to be when we get all the way around over here and I have a negative over a negative. Well, that's actually the same as when we put our coterminals in here, that plus pi n. 7 pi over 6 is going to be the next time it matches up. Then it's going to be 13 pi over 6 to be the next time it matches up. Because on our unit circle, if I filled in over here, these would all have a negative term. We're going to have our negative 1/2 square root of 3 over 2. This would be a negative square root of 2 over 2. That guy. And then this guy would have our negative square root of 3. Positive 1/2. So on the left in quadrant 2 or in quadrant 4, my tangents are going to be negative. So since this is positive, I'm only looking for quadrant 1 and quadrant 3, which is included in our coterminals here. So in this case, our tangent's only going to have one answer. The only reason our tangent had 2 answers on the last one is because we had that squared, where we had our plus or minus, where we needed our positive square root of 3 and our negative square root of 3. So that one had 2 answers in here. Since this one was not squared, we don't have a positive and a negative. That's why this one only has 1. Okay. Just one second, let me check a thing real quick. Just because I think we're okay on time, but I want to double check. Okay. So we can go ahead and stop right there. It gives you about 5 more minutes where you can look at stuff. I'm going to put the questions up there, but I'm going to stop right there. Just because our next couple ones get into something it's a little bit funky, and I want to give a chance for everyone who's doing our mock exams today to get this far, catch up, ask a couple of questions tomorrow, and then we'll get into some of the kind of funkier ones. So I'm going to put up the homework questions in case you don't have them over there. And this also has our next couple of quiz dates on here, just so that we have them, so that everything's up there and apparent and available and all that jazz. So tomorrow we will keep working with our solving stuff. 7-2 is a lot of solving. Some of them are just like the ones we just did. Some of them are going to have a little bit extra. And then some of them are going to get a little wild. But I don't want to go too far without all of our friends in here. Because tomorrow we're going to start doing some substitution in there when we're doing solving. Oh, snap. What?